This assessment asks us to calculate the specific rotation for this particular molecule given these parameters. Our equation for specific rotation is to take the observed rotation and divide by the path length and the concentration. The path length is given to us. It's a 1 centimeter polarimeter cell, which is a 0.1 decimeter cell. The concentration, though, we're going to need to do a little bit of work. Let's calculate the concentration. The concentration needs to be in grams of compound divided by 100 milliliters of solvent. So our concentration right now is 50 milligrams of compound in 10 milliliters of solution. We can do a quick dimensional analysis to convert milligrams to grams. There are 1,000 milligrams in 1 gram. That means our concentration is 0.05 grams in 10 milliliters of solvent. But I need this in 100 milliliters of solvent. So I'll need to scale this by 10, scale it up by 10 in order to get 100 milliliters of solvent. That'll be 0.5 grams of compound in 100 milliliters of solvent. This is the concentration I can use for this equation. For my equation then, the alpha, the specific rotation at 20 degrees Celsius using the sodium D line, standard conditions. The observed rotation is negative 1.58 degrees. Dividing that by the path length is 1 centimeter. That's 0.1 decimeters. And our concentration we just calculated to be 0.5 grams per 100 milliliters. We go through and do these calculations then. Our specific rotation is negative 31.6 degrees.